A-level math students, make sure you know how to answer parametric differentiation questions like this for your pure papers coming up this week. So we're given this curve, which is described by this pair of parametric equations here. T runs from minus pi over 4 to pi over 3. We're told that L is normal to C at the point P where T is equal to pi over 4. And in the first part, we're asked to use parametric differentiation to show that an equation for L is given by this expression here. So whenever we're trying to find the equation of a normal to a curve, it's exactly the same as with sort of what you would learn in year one. We need to find the gradient of the tangent line to the curve at that point. And we do this by evaluating the derivative of the curve at that point. And then we can calculate the normal as you would, GCSE using the negative reciprocal. So that means we need an expression for dy by dx. And, as normal, in parametric differentiation, we use the fact that, which is essentially just the chain rule, right, that dy by dx can be expressed as dy by dt times dt by dx. However, here, because we're not explicitly asked to find an expression for dy by dx, I don't really need to find an explicit expression, for dy by dx. I can use the fact that dy by dx evaluated at t is equal to pi over 4, which is what I'm interested in, is just the same as calculating these two things, right, and evaluating them at t is equal to pi over 4, right? So you don't have to worry about actually finding the explicit expression, not that it really makes much difference, but, it can save you a little bit of time. So what we need to do then is calculate these two derivatives and then evaluate them at t is equal to pi over 4. Of course, dt by dx is just 1 over dx by dt. That's true for sort of, ordinary derivatives like this in one dimension. So let's go ahead and do this, okay? So we'll start off by differentiating x here, so dx by dt, and sorry, I'm just trying to work on this page, so I don't have to kind of get another bit of paper, but I probably will at some point. So dx by dt, well, again, if you don't know the derivative of tan, that's fine. I mean, you should be able to work it out, but also you are given it directly, so you can just read it off on the formula sheet. Same with sec, we're going to have to use the chain rule for sec squared. So differentiating this, that just gives us 2 sec squared t, and then dy by dt. So as I said, using the chain rule, so this power of 2 comes down, and then we have to differentiate the inside function. So the derivative of sec is actually sec t tan t, and then we still have a factor of sec t left over. So that's going to give us the following. That gives us 4 sec squared t tan t. Okay, so then evaluating these things at t is equal to pi over 4, what do we get, right? Well, I'm remembering here that we need to take the reciprocal. Well, if you evaluate sec squared at t is equal to pi over 4, it turns out to be nice, right? Because cosine of pi over 4 is just root 2 over 2, and this 1 over that, etc. squared. So this just gives you 2. Tan of pi over 4 is just 1. Okay, so this gives me 4 times 2, which is 8. Okay, so this is 8. And for dx by dt, evaluated at t is equal to pi over 4, well, we said already sec squared t